Hello, everybody. Welcome to another episode of the Subnet Show. I am your host, Gabriel Cardona, and I'm very stoked to be here with you tonight. And I'm joined, as always, by my amazing co-host, the man with the most cats in crypto, Connor Daly. What is up, my friend?
You guys, we got one. We got one.
Real time.
I was gonna say he's on my lap out of frame, but no, he's just getting up just so we can bump the microphone and just ruin my setup. Yeah.
Is that Ollie?
This is Ollie.
He's always around. Was he yours? Like, is he your favorite or what? Is he your buddy?
Number 3, number 4 in the ranking. He was mine though.
He's trying to get up to level 2 or 1. That's why he always hangs out.
Well, it's actually more that he hangs out because he fights with the girls and cannot be left unsupervised with them. So he has to be in here with me when I'm in here.
Nice. So we are joined tonight by one of the amazing people from our platform team and the actual creator of Core ETH, which is our C-Chain, which has now sort of been ported into the Subnet EVM, which is going to absolutely be blowing up. I don't know your official title, but you can let us know. But we're joined by Aaron Buchwald. How's it going, Aaron?
It's going great. Excited to be on the show again. I think for official title, I just am a software engineer. Nothing too crazy, but
yeah. Did I say your last name right? Is it Buchwald or Buchwald?
Buchwald. If it's a German last name, so if you're in Germany, it would be Buchwald. I lived in Germany for a while. I know Connor, you speak German too. So everyone there thought they were supposed to call me Buchwald. But in America, I've always gone by Buchwald, and I was kind of surprised that it was actually something else somewhere else. Connor, what do you want to call me? Buchwald or Buchwald?
Well, I was going to say, I'm going to call you friend of the show, as this is now your
right,
second appearance.
Sure. You're in now the elite class of people who've made it back multiple times on the show. So thank you very much. Yeah, as I mentioned, Aaron's claim to fame that I know of, although I'm sure he's got other cool stuff, is number one, are you still at Cornell? Did you graduate? Are you still in classes? What's going on there?
I graduated, yeah. So I finished up over December. Actually, I guess I finished in January, so I'm all done now. I'm still based in Ithaca for a little while longer. But yeah, all done, working full time, and that part's not much of a change, but yeah.
Congratulations. I know that's a huge milestone. That must feel good.
There are a couple of people at Ava Labs who took on some really extreme workloads that I have no idea how they pulled it off. I was a Cornell undergraduate and was completely swamped and like destroyed by my course load for like several semesters. And I could like barely keep up like a 10-hour a week like research project on the side, much less a full-time plus job. But some people like Mr. Book Forest over here, they are able to juggle a full-time course load and full-time employment and still end up being one of the biggest contributors at the company. And I have no idea how you do it. Do you have like one of those time turners or something that I need? I need to learn your strategies.
When Zach would go time.
I recently got into the Pomodoro technique with the little time. You set a timer for 25 minutes and then take like a 5-minute break. I found that it worked pretty well for a little while, but then I just would like turn off the timer because I was busy with something, and then I would just work throughout the entire day. So it wasn't really for me. Probably could have stayed more dedicated to it, but kind of gave that up. But it was something I experimented with. I did actually though. I read one of your Twitter threads, Connor, actually about, I think it was not the Notion app, but I think you said something about all of the different note-taking apps that you're experimenting with, and I ended up going with Notion. But what was it? What was your thread about?
I use Obsidian.
Obsidian, okay.
Yeah. I'm very into knowledge management, and I spent a lot of time last year kind of like working on like a digital garden kind of style of workflow with a lot of notes, and actually taking my notes and putting them into a digital format for the first time and basically writing there exclusively. And I think that has just paid like huge dividends in my life, because it actually made all of the stuff that I would write down over years indexable and kind of like link it together. So, and I wouldn't lose stuff. I no longer forget stuff. And it really made it, really made a huge difference. I honestly, part of me does think of my life in terms of before I started doing this note-taking workflow and after, because just the compound interest is crazy there.
Yeah, that's like one of the soft skills that you never really talk about in job interviews. It's kind of like, how organized are you? How do you handle stress? How much stuff can you keep in your mind at one time? How much old stuff can you still remember, right? So you have this institutional knowledge. So we always ask people about their hard skills. Can you code in TypeScript? Do you know Git? Like, kind of, have you ever worked with Jira? That kind of stuff. But then there's just so many other soft skills that I think really make you successful. And organization is one of them, because we're all just drowning in incoming stuff. Like, just how many DMs do you get a day alone? You know what I mean? Like hundreds of DMs every day. That alone is a full-time job, not even doing any of my other stuff. So just being organized is pretty good. Pretty good.
I apologize to everybody that ever writes to me on Twitter, Discord, whatever.
Me too.
I replied to somebody today who wrote me in like early February. Like, this is the best I can do, man. Like,
I think people understand. I think people understand where we're at this point.
I can't do Slack, Telegram, Twitter DMs, Discords. It's too much.
Email, Facebook, like email. It keeps good.
Here's the truth. I just gave up on email.
Yeah. And WeChat. If you ever travel in Asia, everybody uses WeChat there. So I've got an entire tribe of people who only ping me on WeChat. So that's a whole other thing I've got to be dialed in on, like WeChat. I don't even go to Asia. I haven't been there in 2 years. Okay, so we have some really cool stuff to talk about this week. As I mentioned, we have Aaron. Aaron is the creator of the C-Chain, which is absolutely amazing. Recently, we passed 100 million transactions we talked about last week. We're now at like 109 or something today. We're doing about 1 million a day, right around it, right below it, right above it. Absolutely amazing traction. There was one thing I wanted to talk about prior to that, and I'm going to share my screen very briefly, simply so I can show you guys this graphics. So you guys see the Medium post, correct?
Yeah.
Yes.
Okay, cool. So recently the CCRI, and I will link these articles, or myself or Connor will put them in the description box below. CCR finds that Avalanche consumes 35,000 times less energy than Ethereum and 200,000 times less than Bitcoin. The Avalanche public blockchain uses just 0.0005% of the amount of energy consumed by the Bitcoin blockchain and only 0.0028% of that of the Ethereum network. And another way they say it, which is a nice way to visualize it, is that Bitcoin consumes the same energy as 8.5 million US households in a given year, and Ethereum consumes the equivalent of 1.6 million US households in a given year. By contrast, the Avalanche network was found to consume the same amount of energy as only 46 US households, with the average US household consuming, it says 10,000.6 kilowatt hours per year. Here's another way to visualize it. So this is just really, really big news. And I think there's a couple of things going on here. Obviously, we use proof of stake instead of proof of work for our Sybil protection. And so that's one reason, proof of stake is different than proof of work, which is kind of just continuously playing this lottery number over and over and over trillions of times across all these computers. Proof of stake obviously is different than that. And then also Avalanche consensus is different than Nakamoto consensus, in the sense that Avalanche consensus is quiescent and green. Here's another nice little chart. And so in the event that there are no consensus messages being passed around, the entire Avalanche network will just chill out. But as I just mentioned, us doing 1 million transactions a day on the C-Chain, I don't suspect that there's many times where that's happening. We've been seeing bursts of maybe like 150, 200 TPS per second each day on the C-Chain. So on the primary subnet, I'm not sure there's a lot of time when the entire network chills out, but it might be a little bit different on subnets. But I just think this is really, really important. I think we're living during this time where we're seeing human-driven climate change, and I think that's obviously a hot button topic for some people. But there's a spectrum about what people believe. But I think at this point, it's pretty clear that humans are having an impact on the Earth. And I have this theme that I keep harping back to, and I've been saying it for a couple of years. I'm a big fan of trying to extrapolate into the future, and I like taking a couple of data points and extrapolating far out, even though you're not guaranteed to end up there just from the first couple of data points. But it's been my intuition for the past couple of years that we are right on the verge of seeing a generation of technology which is in balance with nature, this idea of biomimicry, right? So we have all these systems in nature which end up being able to find these symbiotic relationships and ultimately sustain over long periods of time. And that's something that our current society doesn't quite have dialed in yet. I don't know that our way of living is totally sustainable, right? If we just stay on this current track, what's the world going to look like in 100 years, 10,000 years? I'm not sure. And that's why I'm confident that necessity is the mother of invention. And there's just, if this is going to sound incredibly crass, but if for no other reason, then there's just so much value, both financially and non-financially, in getting the systems of our world into a sustainable state. If for no other reason than simply being driven by profit and a greed motive, which again sounds crass, but I'm just very confident that humans will create systems which are sustainable in the long term. Part of it will be driven by altruism. Part of us realize that, we don't want to pass on a crazy destroyed world to our children. And then some people will just be strictly driven by greed. And I think there's probably a spectrum of in between, but I really like this, this news right here, simply because you guys know that I believe that the blockchain is going to be as transformative as the web and potentially greater. I've often said, in the same way the web took the totality of all human knowledge and made it ubiquitous and available at the click of a button, the blockchain has the potential to do that with finance and money. And of course, that's incredibly transformative. And so you would expect systems, or you would hope the systems would emerge, which would, have these type of traits. So I think this is huge. A couple other thoughts, and then I'll pass the mic. Every single hour, enough energy falls on the earth in the form of sunlight to meet greater than 100% of our energy needs, including fossil fuels and nuclear and biorenewable. So every hour we get greater than a year's worth of energy in the form of sunlight. The problem is harvesting it, storing it, and transporting it. But I believe that's what's happening right now when you see things like, Tesla or Solar City or all these other startups. I just read the other day that solar power is the cheapest form of power in all of history, and it's getting cheaper every day. So I'm not entirely positive that the proof of work burning energy thing is a long-term problem, but it's most certainly a short-term problem. And it's a short-term problem in multiple ways. We're burning a ton of energy and not getting a lot out of it. Like how much value is the Bitcoin network actually adding? A lot, probably, as a store of value, but not a ton as a medium of exchange. And then, but perhaps more importantly is it gives bad optics into the cryptocurrency industry. So, a lot of people say, what is the value of cryptocurrency? You're burning up the entire world and you get a handful of transactions a day, because they're, of course, thinking about Bitcoin. So I just think this report is incredibly valuable and incredibly important, because it just shows that, Avalanche really is a green and an eco-friendly and a quiescent network that is using just fractions and 38,000 times less or whatever than Bitcoin and Ethereum. And that's pretty awesome. I suspect Ethereum will change once they go to proof of stake, but they still won't be using Avalanche consensus. So they'll still be using Nakamoto consensus. But let me pass the mic around. What do you guys think? What do you think, Connor?
Yeah, so I think there's a couple things to add there. So one, some users might be interested, like, well, Solana doesn't use proof of work. So like, why is Avalanche so much less than Solana in this graph? And, what I would say is that Avalanche consensus is very much a network heavy protocol. And we were able to make a lot of optimizations on the networking level. So you don't actually need a lot of really high hardware specs to run a node that can participate in Avalanche consensus. So most of our validators, of which there's about 1,200, use like medium tier cloud machines. They don't need like 128 gigs of RAM or 256 gigs for like a really beefy machine that Solana, something like Solana would require. And so because we also have smaller hardware requirements, that helps keep our costs down. And yeah, to echo your points, I think you're exactly right. Even if all of crypto runs on clean energy, there's still a lot of negative externalities to proof of work that Avalanche consensus helps us move away from. I mean, look at the demand for silicon and how that has affected like the GPU market. So if you could get rid of proof of work, you could actually play PC games. Those are like, even though that's not necessarily like a kind of a climate change region, there's a lot of externalities which Avalanche solves. So definitely.
Sorry about that.
Definitely. Yeah, and this also affirms a lot of the other reports we've seen. From I know we worked with Materium to try to get another certification. We actually did buy a set of carbon offsets to offset the environmental impact that we do have. So, by some accounts, we are carbon neutral, though I know people calculate some of these numbers differently, so it's hard to say. But yeah, Aaron, what are your thoughts?
Yeah, I mean, I think obviously you look at this graphic and it's great that we've made a large improvement. I think the reason Avalanche was founded was, looking at the crypto industry being what it was. The founder, Agun, really just kind of saw we can do better. And this is kind of showing like a realization of that vision that at least this metric, and this is an important metric to me, I think, is that like we are doing better in terms of using less energy. To follow up on a combined point from you guys on, just even if we are using 100% clean energy, if we're using more energy than we need, there's still a negative externality because, we've gotten to a point where we've used the world is in kind of a bad place in terms of climate change. We have a lot of carbon that's already in the atmosphere. So the less that we can use, the better, right? So we have to, like, if you're thinking about combating climate change, you have to create more sources of clean energy. But that's not really enough. You have to also continue to use less because it's kind of a race at this point, right? In order to replace those bad sources of energy. So whatever we can do to reduce that is great. And so I think the fact that Avalanche has made a big step here is awesome. And I think also, everyone, we've always known that we were going to be way more green than these other proof of work protocols, just based on the fact that we're not doing a complex hash puzzle. If you look at the infrastructure that Bitcoin and Ethereum and other proof of work protocols are running on, they set up massive mining rigs using all those GPUs that you mentioned, right? It's a very, very heavy intensive protocol that's using a massive amount of electricity. And the reality is, that's part of Nakamoto consensus. That's very, very tightly coupled to their consensus protocol. So Ethereum moving away from that is going to be great too, because they're obviously a massive network. So you can see there is at 17 billion kilowatt hours. That's going to be reduced drastically when ETH2 hits. So that's going to be a fantastic thing because they're not going to be using nearly as much. They're going to be shifting away from proof of work. And it's great to see also that Avalanche is doing even better than Solana in terms of the amount of energy that it's consuming. And one comment to add to that, I think part of that might be Solana is based on a proof of history type of protocol. And so a large part of that is that they are taking hashes over and over again in a somewhat similar way to how proof of work behaves. They're obviously not in the same competitive market of everyone's trying to create that as fast as possible, but part of their protocol is based on taking hashes repetitively, which can be easily verified as correct if you have all of them by parallelizing it. So you can basically prove that you've spent some amount of time doing something. And so that makes it a very hashing driven protocol. And that's a very complex and expensive operation. That's, I think, probably part of what makes Solana a little bit more expensive. And also the way that they verify that proof of history is by parallelizing that operation. So you have to parallelize that along a large number of cores in order to verify all of that. And that takes up a large amount of computation. Avalanche is actually a surprisingly not nearly as parallelized as Solana is. I mean, the consensus engine itself is pretty much single threaded. It's handling messages one at a time in sequence. And so it's not actually nearly as parallelized. So it's using much less hardware to reflect that. It doesn't need to use 16 cores necessarily because not all of them will be used by that actual consensus protocol. So yeah, I mean, I think this is absolutely fantastic that we've made this big development. We always knew that we were going to be more green than a lot of other protocols, and it's great to see that verified and published by the Carbon Credit Rating Institute, I think it's called.
That's amazing. And also, please correct me where I'm wrong here because I'm not on our consensus team. But as I understand it, at a super high level, having looked at how the Snowman algo works, there are certain constants like the number of validators or like the number of whatever K is. I forget exactly what K is in our algo, but I believe it's 5. What is the constant K? Do you remember?
Yeah, so K
is the number of samples, right?
Exactly. So it's the number of samples in a given round. So the way that it works is we are a repeated subsampling based consensus algorithm. And so K is the number of nodes to sample in a given round. And alpha is the number of nodes that have to report a positive response in order to increment our confidence for something. So for example, and right now K is 20, I think alpha is 16. I could be slightly wrong on that.
Right. So the reason I mentioned it is I was my thought here was as far as I understand, so the number of consensus message stays constant despite the number of validators in the set. So if we had 1 million validators in some future world, there would still be the same number of consensus messages. So I'm wondering, will the Avalanche network still use a similar amount of energy as more and more validators come online, or would we expect that to change? That's one question. And then how do subnets affect the amount of energy we're burning? Will it go up like crazy then, or do you have any insights on either of those questions?
Yeah, so a couple of things to dial in on there. So for the first question, so we are doing this repeated subsampling algorithm. So regardless of if right now we have about 1,000 validators, if that goes to 2,000, K doesn't need to change. K can still be 20. So the thing that does change, however, is if you have 2,000 validators to sample from, and it's more a diverse validator set, then the thing that's going to be important is how quickly do those validators move towards accepting something. So when you ask someone, what do you think of this? If it's their first time hearing of it, they're not going to be able to vote positively like, yes, I have that. And I can say, yes, I verified this. Therefore, I'm on the path towards accepting this. You should too. So the one thing that happens there is even though our K stays constant and we'll be sampling the same number of validators, that's not going to change. What we might see is a slightly larger number of rounds that it takes or a little bit longer of a delay. And the reason for that would be, like those transactions that are being verified or those blocks that are being verified in the case of Snowman, they haven't been propagated as much. Like if the network becomes more globally diverse, a larger number of validators, that's the main thing that's going to change. Additionally, you do have to keep a larger number of network connections. So as that scales, there's going to be a little bit more electricity used up there. And then lastly, of course, if we have 1,000 validators that turns to 2,000, that's going to double the amount of electricity, roughly speaking, because they're all running the same protocol. Gotcha. That'll be not quite an exact science, of course, but the more validators we have, it is going to use more energy. And so there's a bit of a trade-off between how decentralized we want to be versus how much energy is that going to take up. Because if we have 5 times as many validators, we're using, roughly speaking, 5 times as much electricity. Are we getting a good trade-off there? Or are we happy with the level of decentralization of 1,000 validators?
You can also kind of control that by the delegation threshold. And do you want to incentivize people to delegate to existing validators, which doesn't actually cost any additional energy, but does help secure the network versus actually incentivizing people to stand up their own machines?
Yeah, I mean, it's great when people delegate instead of validate as well. I mean, I think more validators is definitely better for decentralization. If somebody delegates, they're not really participating. They're delegating their weight to someone that's already in consensus, but they're not really adding an additional party that's a member of consensus. They're just putting their weight behind someone. So it doesn't add to the level of decentralization as much as adding a new validator does. And also, most people, when they delegate, maybe they delegate to a node that's of somebody they know, maybe they delegate to a known operator. But a lot of the time, people delegate, they go to Avascan, and they see somebody's node who's been operating for a while and has like 99% uptime, and so they delegate to that, which isn't necessarily something that they've verified that information that it's going to be a good, correct node. So there are trade-offs there to whether or not we're actually getting more decentralization out of delegations, but certainly that's a lever that can kind of be played around with. If it's a much lower delegation threshold, it's 25 Avox, I believe, as opposed to 2,000. It's 25 Avox to delegate as opposed to 2,000 Avox to validate. So a lot of people who have maybe 100 Avox, 200 Avox, which is a decent amount of money, will choose to delegate instead of validate. And honestly, if you have if you're investing that amount into some form of validation, either delegation or validation, delegating or validating, then it can end up being a better investment of your money. Because if your AWS costs are roughly fixed at maybe $100 a month, if the 2% fee that you're going to pay to the validator in order to delegate to them is going to be more than that, or sorry, if it's going to be less than that, then you might be better off delegating. But once you get to a much larger amount, then it typically is a much better investment to validate. It depends very much on your technical expertise too, if you would prefer to run your own node or not.
All right, I want to change this conversation up a little bit because we have, like Gabriel said, the guy who created the C-Chain, which this is, when we talk about the history of Ava Labs, when I joined, literally, you were the C-Chain guy. This blockchain, which is now basically top 10 in the world, that has many $1 billion of assets on it, was kind of created by like one guy. Honestly, the X chain was like the team's first priority back in late 2019 or late 2020. And you were the C-Chain guy. Now there's the whole platform team of like 15 people that work on various parts of the C-Chain.
20 now, actually. We're still growing.
20?
Yeah.
They won't let me hire anybody. My God, they just take them all for themselves.
Yes.
But yeah, you have like incredible technical expertise on the C-Chain, and you've been working on some really cool stuff that we wanted to highlight. And so the first thing I think we should touch on is this new feature that we've added. So you've also been deeply embedded in subnets, but the first kind of the most popular subnet that we see in the next few months is going to be our Subnet EVM, which is basically standing up your own copy of the EVM whenever, with whatever changes you want to make.
Yep. There's the PR from today. That's the feature we're going to be talking about, that last commit right there.
Yeah.
There it is, number 31.
When you create a new version of the Subnet EVM, you can make changes to the EVM. And when some people ask, well, what changes would I want to make? Well, there's one particular change that you added. I forgot what they called. Forgot what it's called. So why don't you take it away and tell us about your stateful precompiles?
Yeah. Stateful precompiles is what I've been calling them. This is actually something that we kind of came up with a while ago, but we just kind of realized that we could use it in a much more interesting, much more powerful way. And so that way is probably going to be in creating new custom VMs built on top of the Subnet EVM. And just to correct one thing here with Subnet EVM is we're realizing now a bit of a misnomer, because when you create a subnet, you can deploy an instance of a virtual machine to that subnet. And we're realizing now that a lot of people see Subnet EVM and they think that is the subnet, but a subnet is actually a validator set as well as a group of blockchains that are validated by that validator set. So we might need to change the name of this. It might be a little bit too late to do that. But just to clarify one thing, Subnet EVM is a virtual machine that runs a blockchain. So it runs on a subnet. You can actually have multiple different instances of the Subnet EVM on one subnet. So we'll see if we decide to put in a name change there, because I'm not sure that's very clearly communicated. But yeah, so the interesting thing that we've been developing is stateful precompiles. And so this derives from the notion of precompiled contracts from Ethereum and their version of the EVM. And so what the precompiles are in the EVM is it's a way to do mostly complex cryptographic operations outside of the context of Solidity. If you're trying to do a BLS signature or just verifying any kind of signature or some hash operation, to write out how to do that in Solidity would be extremely expensive and also very, very complicated to write in Solidity, and nobody really wants to do that. And so the notion that they developed is this concept of a precompile. And so what it is you can pass in some arbitrary input data and to some address in the same way that you call a contract or a smart contract in the EVM. And so it passes that input data in and it returns some value, which is usually a hash or their signature verification or some crypto operation. And the reason they do this is it would be very expensive to do in Solidity. So they made this easy for everyone. It's a really useful utility for lots of different kinds of smart contracts. So what we did in order to implement stateful precompiles is we added in state access to these precompiles. So for the crypto operations, they obviously don't need any access to the state. They don't need to read anything from the state. They don't need to write anything. But once you actually provide access to state to that interface, then you can start to implement lots of different things. And so this is going to be really, really interesting for everybody that wants to have their own instance of the Subnet EVM if they want to have some level of customization. Because once you have that, you can do various state operations and you can do them entirely in Golang. And so that becomes really cool. So what we did this week, or the past couple of weeks, was we implemented a stateful precompile and built out an interface for it and made it as easy as possible for people to build new ones. And so the first one that we created was an allow list, which is a list that basically says, does this person, does this address have rightful access to this resource? And so we implemented this specifically for some of the people building on Subnet EVM that are launching their own instances, largely in GameFi, where they want to make sure that they are the only people that are going to deploy a contract to their chain. If you're launching some game to a subnet, you don't want to compete with anybody else's project on that subnet. You literally just want to create it for yourself and for your users, and then have some connections back to other ecosystems. Well, you want to control it yourself. So what we did is we created an allow list for contract deployers. So what this does is only your set of admin addresses, you can see there, that's the EWA key starting with 0x8VB. Yep, right there. And so only that address will be an admin for over this allow list, so it can configure new people, enable them, as well as add new admins, remove admins, etc. or make it so that people and anybody not on this allow list won't be allowed to deploy a contract. So this is a really powerful construct for a lot of the people building on Subnet EVM right now. And once you have this kind of interface where you have access to state, there's really no limit to what else you might be able to build. And so the way that we actually made this is that if you pull up in precompile allow list.sol, actually, if you just scroll down in this README, I think it's below this, you can see that there's actually an interface to this precompile contract. And so what you can actually do is just create the interface in Solidity and then implement it entirely in Golang. So this allow list interface is implemented entirely in Golang, but you can still deploy this or use this interface and deploy this to Remix and interact with it entirely from there or any other tooling that you want. So previously precompiles, you just passed in input data. But now what we basically did is we make it so you can create these functions and actually make Go programs execute behind them with that access to state and do whatever you might want. The only requirement there really is that they have to determine its executions that different validators running the same code don't end up with a different result, which would obviously break consensus because people would execute the same thing and arrive at a different result. And the way that this works is essentially when you have a smart contract built in Solidity, it has to, when you execute that smart contract or send some input data to or interact with it, do a smart contract call in some way, the way that it determines where to jump to in the code is by using what's called a function selector. And so that function selector is the first 4 bytes of the KESIC 256 hash of the signature. And so what we do in this contract is we have the input data, and what we do is we check to see the first 4 bytes, and we check for any matches to function signatures that contract is implemented. And so if we find one, we can use that execution function. And so once you have that, you can define whatever arbitrary logic you want, implementing an exact interface. You can have multiple different functions on one precompile, and you can essentially implement any type of smart contract that you might want using this interface. So it's really pretty powerful. And what we're really expecting and hoping for is that anybody that wants to launch a Subnet EVM, but they want to have some slight modification, is going to get a lot of value out of this. Because if they want to launch some modification, they now have a very clear interface to write whatever function that they want, do literally whatever they want in Golang, and deploy that as a smart contract or treat it as a smart contract externally. So whatever utility the EVM is missing that would be useful for really any application, they can create that very, very easily out of this. So that's the goal. That's the hope, is that this is going to be an extremely usable, very, very easy to use tool for anybody that wants to customize the Subnet EVM.
Wow, that's great.
So one thing,
go for it.
I've never heard anybody pronounce it Kesak.
Yeah,
I've always said Kekak. You could be right. I'm just surprised.
No, I'm probably wrong.
I've never heard anybody pronounce it any other way either, but it's
I don't think I've ever heard anyone, actually, no, I definitely heard people pronounce it. But it's one of those things I never picked up.
So to like kind of reiterate this, just to make it like super clear for our listeners. So yeah, so if you've ever coded in Solidity before, so these Solidity before, you might have used these functions, but yeah, so basically, all of the operations in a Solidity smart contract get compiled down to EVM bytecode. So it's just like when you write a C++ program, it gets compiled down to like x86 assembly for your machine. It's a series of small bite-sized instructions for like add, move, store this value, load this value. And constructing a big cryptographic operation would just be hugely expensive. And so these precompiles are a little cheat code where basically instead of running the function in the Ethereum virtual machine, it actually runs it on your like main computer to get the results, so that you can do expensive things like compute a hash function or do a signature recovery. So yeah, if you've ever used the Kekak 256 function or like EC recover, those are all precompiles. And so this tool expands what those precompiles can do and makes it even easier to use them. And what are some of these things useful for? Like, why would you want to expand this besides the allow list? When I was reviewing entries for the Morales hackathon, one of the proposals that I saw that I thought was super cool was one that introduced a random number into the block header of an Ethereum block. And so there's a lot of issues with randomness in smart contracts. And so this guy's solution was let's include a verifiably random number in each block so that people aren't using like the block hash or something like that that might be gameable. There definitely is some gameability still to this, so I wouldn't take this solution verbatim, but it's just kind of an illustrative example. So you can actually, if you have this random number, you still need a way to access it because there's no Solidity native way to just say like, get me eth.random number, because it doesn't exist in mainline Solidity. There's no Solidity compiler that has the ability to grab this value. So you kind of have two options to do this. One of them would be you could modify the EVM to have an extra instruction and an extra opcode. But then the problem is you don't have you'd have to modify all of your Solidity compilers to support that operation. The alternative is you could do a precompile like Aaron just told us about. And then in your code, instead of having to do some like EVM assembly, you can actually just call a function and it's there. So if you have cool ideas to extend the EVM, like this is the way to do it. And you can do, this is, an instance where you can do more on Avalanche and Solidity than you can do on Ethereum now.
Yeah, so yeah, there was a few questions that came to me from that. The first one was, presumably this is not available on Ethereum, and I guess Connor just answered the question to that. The second one was, can you guys think of some examples other than cryptographic functions that you might want to do as a precompile? So that's one open-ended question. And then the last one was something that I've been super excited about, and I've talked about a ton in the past, and I was hoping that Aaron could maybe give us like and explain it like I'm 5, is the ability to write VMs in non-Golang languages and use this grpc API. So before we get to that one, are there other examples that come to your all's mind other than cryptographic operations that you might want to use this for? What other things do you guys expect to see?
Yeah, I think one of the most exciting ones, and I'm not exactly sure what the timeline is going to be on this because we are very busy working on lots of things. But one exciting potential opportunity is to have precompiles for atomic transactions. So right now on the C-Chain, atomic transactions are executed completely outside of the EVM. They are a foreign transaction type that we basically injected into the block, and they're executed and verified separately from the EVM code. And so those allow us to transfer assets between the C-Chain, X-Chain, and P-Chain, and back and forth. So the interesting thing that we might be able to do is to use a precompile in order to support that same type of operation. And that if we can do that, that would be a really very cool thing. So we'll see if we can make that happen.
It's something really out there. I don't know how practical this would be. No, so this is, I'm gonna throw something out. So like, I think this would be useful for anything that is like computationally hard, but would be significantly like repeated. So let's just say you wanted to do some like blockchain machine learning hybrid, and you had like a neural network on your subnet, and you needed to like run the neural network, which has an agreed upon state, like to classify an object or something like that. You could make the classify operation a precompile to remove that like compute heavy task from the contract. So you could do some crazy stuff like that. I'm not sure that's actually a good idea, but that's my crazy idea for the day.
Okay, very cool.
I mean, the cool thing about virtual machines is, you can implement them. You don't have to use the EVM. So I think the one thing there would be, it'd be very interesting to see what context you wanted to apply that machine learning algorithm to, and like why it would make sense to do that on top of the EVM or include it. And if you did that, and then there was some other ecosystem there too, that could be really, really interesting. And
I have no use case. I have no use case other than buzzwords.
Yeah, there are lots. Yeah, we can throw more in.
Is there going to be an easy way for people to share their precompiles? Will it just be through GitHub, or is there going to be some other way to do this kind of thing?
Yeah, so if anybody has an idea for a precompile, they can make a PR to the Subnet EVM. If it's something that's interesting, we can kind of assign it a canonical address there. And it can, with the way that we're doing this, all of these precompiles are going to be optional. And so people can configure them in their chain config, deciding whether or not to enable them, as well as doing a network upgrade in the future in order to enable them. So for this, allow us, obviously not every instance of the Subnet EVM wants to have restrictions on contract deployers. A huge number of them, probably the majority, will not want that. They'll want to make it as open as possible, allow anybody to deploy a smart contract there. So that's obviously going to be optional. And if anybody else has new ideas, they can make a PR. We'll take a look at it, make sure everything works. And if it's something that the community wants, then we'd love to have more contributions. to the Subnet EVM. If there's something useful, or if there's anything somebody wants, if they want to make a GitHub issue, we can see if we can build it out. And one of the cool things there is right now it has access to state, but the way that state access works is just a key value pair where both values are 32-byte hashes, which means that it's a little bit complicated to store something that's larger than that. So we are going to, in the future, if we want to make this interface more powerful, kind of take that capability and make it more powerful so you can store larger pieces of data and do more interesting things on top of that. So we'll see what we can do there. But yeah, if anybody has ideas, feel free to make a GitHub issue or pull request, and we'd love to build out more functionalities here.
Very cool. So then the next part of the question around the grpc and the VMs. I know we have the rpcchainvm, which I believe it's called, and basically there's a grpc API that if you implement in another language, you can run your VM in a separate process than the Avalanche Go process, and it will act as a grp server, and then there's a grpc client in the main Avalanche Go process that can call into it. That's my extent of the understanding of that. So I might not even have got that correct. Can you give us an explain it like I'm 5 around the grpc API and the grpc VM, that whole thing?
Yeah, for sure. So to give some background on this is the way that we used to run the C-Chain. And the reason for that was there were some licensing issues where we were told that we weren't allowed to run core ETH in the same process as Avalanche Go. Since then, we've realized that that's not actually necessarily the case. And so we're now running core ETH in the same process as Avalanche Go, and it's no longer going over the rpcchainvm. But it's still a really powerful construct if you want to run a VM either in a different language or in a different process for whatever other reason. And so the way that this works is there's a grpc layer where the Avalanche Go can communicate with an arbitrary subnet. Anybody that wants to implement the virtual machine interface and then also that grpc wrapper on top of it can then communicate to Avalanche Go via grpc. So the basic functions that the VM calls, parse block, get block, build block, etc., all of those functions that Avalanche Go assumes that VM interface meets are just implemented in the rpcchainvm as well. And so those calls are passed off and communicated over grpc and then relayed back to the Avalanche Go process. So if get block is called, it just passes in a block ID, the 32-byte hash or the 32-byte identifier of that block is sent over grpc to the plugin process that implements the VM. Get block is called there, and then whatever the result is returned back and sent over grpc back to the Avalanche Go process. At the same time, if that virtual machine needs to access a resource from Avalanche Go, for example, Avalanche Go provides a database that the virtual machine can use. And so that is actually a server that runs on the Avalanche Go side. So when the virtual machine on the rpcchainvm side wants to write some operation to disk or write something to the database, it actually sends a request to saying, hey, get this value, or for example, put this value and let me know if there's an error. And so that goes over grpc in the opposite direction. So grpc basically provides a two-way interface where you can provide resources to that plugin process that are actually being served from Avalanche Go, as well as allowing that rpcchainvm to implement the virtual machine interface and serve it back to Avalanche Go from another process. I think that's the Eli 5. Is there anything I should dive into more? I'm not sure if I was specific enough there, if there's something to get into.
Yeah, I think that makes sense to me. So as an implementer of a VM, is the hard requirement simply that your language needs a grpc library, right? So if I wanted to do this in Python or C++ or Rust or something, that there just needs to be a grpc library in that language? Is that kind of like the hard requirement?
Yeah, so right now we actually rely on this grpc broker from HashiCorp, which doesn't necessarily have a perfect parallel in a lot of other languages, but we're working on simplifying that right now. And so once that's a lot simpler, it'll just meet the grpc standard interface. It'll be way, way easier. And so it'll be way, way easier to write an rpcchainvm wrapper. And so basically what people will have to do is they will have to have in some other language, let's say Rust, for example, they'll have to write a wrapper that essentially meets that same interface where it calls get block on the actual VM that's implemented in Rust, and then serves that data back, and it's able to respond to able to understand and respond to the queries from the Avalanche Go side and back and forth. So you would implement that wrapper in Rust, and that would be one library. And then anybody that wants to build that a virtual machine in Rust could build it and use that library to essentially create a plugin. So the way that Core ETH, it still has this in the code, there's like a binary that you can build, which basically takes, it borrows the Golang rpcchainvm wrapper from Avalanche Go, and it just starts a process as a binary. It serves it. And so then Avalanche Go can connect, send it queries, get responses, and that process can also send requests in the opposite direction in order to get responses for some resources served by Avalanche Go. So once you have that wrapper in Rust or any other arbitrary language, then you can start to build virtual machines in that language as well. So once you have it in Rust, it's super easy to build it there. Once you have it in Java, you can build the same thing there. And grpc is a very standard interface, so there's a lot of support for it. It's just that currently we're using this grpc broker, which is a little bit less standard, so it would be a little more difficult right now. So we're working on making that way easier, much simpler, so it'll be as easy as possible for somebody to implement a new Rust rpcchainvm wrapper, and then all of the Rust VMs that they want to at that point.
Got it. So it sounds like we need to, on our end, move away from the GRC hash broker, I think.
grpc broker. It's basically just it's a really helpful helper. It's a very helpful tool that makes it easier to implement interfaces via grpc. The only thing is, because it doesn't necessarily have an equivalent in every programming language, it makes it harder to do more complex things or it makes it harder to meet that same interface in Rust, Java,
Gotcha.
etc.
So that'd be step one. Step two is somebody creating the Rust wrapper, and then step three will be the VM in Rust. So it sounds like there's still a couple of steps for it to come into focus. Okay, that's pretty exciting. I think there's obviously huge opportunity there, of course. Although Golang is awesome, and I definitely steer people towards it as much as possible now. Obviously, not everybody in the world speaks Golang. And so the more we can allow people to write in other languages, obviously it just blows open the amount of potential VMs by a factor of 1,000 or something. So that's pretty exciting. The other thing we wanted to touch on, before we even go to, we want to talk about dynamic fees, but I just wanted to get your sense, Aaron. What do you think about the C-Chain, man? That's like your baby. How do you feel about it? Is it where you thought it would be?
I feel exactly that way. I feel like it's my baby.
Like, how do you feel about it today? Are you blown away? Or are you like, no, I knew we'd be at 500 dApps a year and a half in? Or are we farther, less far? How do you feel?
To be honest, I didn't plan that far ahead. I didn't think of exactly what is it going to be. I really knew that we had a fantastic team. I knew that we had fantastic founders. I knew that the team around us, especially as we started to build out the BD team more, the dApp squad, I knew that we were building fantastic things on top of it. I knew we were building or bringing in great developers, building out our community in a huge way. And it's crazy to see the number of people that are building on it now. And it's not to say that I didn't anticipate it becoming big. I definitely anticipated it becoming one of the top chains out there. I knew the tech that we had. I knew the team that we had, and this is absolutely the expectation. But I never really thought about it. I never really thought about how much are people going to use this. I never really thought about how many developers are going to be on this or anything like that. And now to look at graphs like this, first of all, that just looks so beautiful. And second of all, to see how large the numbers are on them, it's pretty surreal. It's crazy to see. Yeah, stuff like this. It's funny because whenever people ask me what I do, sometimes they'll say, oh, like, show me your code. And so I'll show them the code, like literally I'll pull up Corey and say, yeah, this is what I do. And then, you know, they don't know Golang, they don't know programming in general, and not that impressed. And then I pull up Snowtrace or stats out of Oxford Network, and they're like, what? And it's cool. I mean, I obviously didn't build Snowtrace. I didn't build stats out of Oxford Network either, but it's cool to see all of these stats. It's really cool to see everything that's built on top of it now. It's pretty amazing just to be a part of that.
Oh, it's amazing. And now that we're seeing some of these dApps that are getting so big that they're going to spin off their own subnets and their own EVM subnets, it's even more exciting. Plus, there's just there's like this ecosystem, and then there's this. This isn't a fully formed thought, so I may stumble across this, but I've often thought of like software ecosystems, software platforms as like ecosystems, right? And then I've often thought of software code bases almost like living organisms in the ecosystem, and the code is kind of like the DNA. And then whenever you see something forked, it's almost like, you know, whenever you have a branch on the tree of life and it splits into two separate species, and the more changes happen on each side, they can no longer breed, right? Effectively, that's the way it works in nature. And it's kind of similar in the software world if you zoom out far enough. And I think it's just very interesting to see what we're going to see in the Avalanche network because of this whole idea of subnets combined with this this open source kind of mentality where people can just take stuff and fork it and change it, where we really do have kind of like this living, breathing ecosystem. And we are going to witness this sort of survival of the fittest Darwinian type of thing, where the ideas that make sense are just going to thrive, like our C-Chain, and the ones that don't, they aren't going to make sense and they're not going to thrive. And, you know, their genes of this particular code base are not going to be passed on. So that's one of the reasons I just really love Avalanche, because I love these networks where you ultimately see these Darwinian sort of evolutionary themes play out over time. And I think we're going to see that if we look at our network in 5 years, 10 years, 100 years, it's going to be very clear where you're going to be able to trace back the lineage of some of these chains, which we can't even imagine now. It'll be, you know, 5th or 6th generation subnet EVMs, and you'll be able to trace back what worked and what didn't, where did they split and which branch died and which thrived. And it's one of the things I just really like about Avalanche, that it sort of acts like that. We have a platform, we have an ecosystem, and we're just going to see which ones work and which ones don't. So very, very cool. So surprisingly, we have actually burned through a ton of time. I can't believe it. So the next thing I want to talk about is dynamic fees. So let's see here. What do we have on the notes? So first, I guess, just give us like I know on the C-Chain we use EIP 1559 style dynamic fees. And do you want to sort of give us explain it like I'm 5, give us a high level on dynamic fees if you can.
Yeah, sure. So the idea of dynamic fees is Avalanche, the C-Chain started out with a static fee, and it was set at, actually at this point, I don't even remember. I think it was 470 nanovox per was like the gas price. Connor, is that right? I don't even know, actually. I don't
You know, I was like, it was 225, and then you're like, oh no, you're right, it was 470.
Yeah, it was 470, and then we brought it down to 225. And so at that point, it was just a network upgrade was to reduce the gas price. It was a static thing where every transaction paid at least that price. And so that meant that even if the network has absolutely nothing happening on it, which at that point, when it was 470 nanovox, was pretty much what was happening. If you scroll really, really far back in that stats.vox, the network thing, you can see where there are very few transactions. And so that meant that at that time, since there was very little demand for transactions or space on the blockchain, we could have done that pretty cheaply. But because the price was fixed, it wasn't possible to do that. And so we borrowed very, very heavily from EIP 1559, from the great folks at Ethereum, which obviously we borrowed lots from. They tweet about how much we borrow from them, and even though they joke about how much we borrow from them, we really appreciate it. Love their code. And EIP 1559 is just a really, really great feature. And so for them, the way that they use it is they have a base fee, which is set on a block. And so that base fee is the minimum amount that any transaction pays. And then transactions can also pay a tip on top of that base fee. And so what happens is the tip is paid towards the miner in order to incentivize the miner to include that transaction in a block. And the base fee itself is actually just burnt. So that's why EIP 1559 was considered as like a bit of a bullish thing for Ethereum, because there was this notion that a lot of it is going to be getting burnt. Not all of the fees will be going to miners. And so there's going to be a little bit of a deflationary effect, that there's going to be less Ethereum in circulation, and therefore it's going to become more valuable. For us, we've always burned all of the fees. So there wasn't as much of a change there. But what we did take was, they also have this notion of, based on the utilization of the gas that's in any given block, the base fee is modified at each point in time. And so what ends up happening is we borrowed that notion where if the actual network utilization is higher than some target, then the gas price the base fee increases. If the network utilization is lower, then the base fee decreases. And so we did have to modify this logic somewhat substantially in order to support the notion that we are not a blockchain where a block is produced every 10 seconds. It's asynchronous. It's closer to every 2 seconds that a block is being produced in our system. And so we had to modify those calculations a little bit in order to support the fact that we kind of have a rolling gas window where how much gas has been used in the past 10 seconds as opposed to in the previous block. And then based off of that, if that's above what our target utilization is, then we can increase the gas prices in order to make it so that it'll become a little bit more expensive. Because if we're nearing what our target utilization is, or if we're going above what our target utilization is, we want to actually disincentivize people from sending as many transactions. We want the system to actually balance out. And so if we're actually largely below what that target utilization is, then we can actually decrease it and make it a little bit cheaper in order to provide not necessarily an incentive, but just to make it cheaper for the people that do want to transact make it easier for them to do so. And so one of the big misconceptions that people have is that the Avalanche network, like when the fees get high, transactions stop going through. This is really not true. What's actually happening is that people were submitting transactions at a gas price that was no longer above the base fee. And so this will lead into a conversation about what is also so cool, not just about the mechanism of adjusting the base fee, but also the dynamic fee transactions that are interested in the EIP 1559 as well. But what actually is happening is the base fee is adjusting to compensate for the fact that there is a higher amount of network activity. And so all of those transactions that are at a base fee of 25 GUI, which is our current minimum, all of those transactions are no longer eligible to be included in a block. So if there are 100 transactions that are sitting in the mempool, all at 25 GUI, but because of the amount of activity that's going on, that base fee is actually increased and is being at a slightly higher sustained level. If it's say like at 50 GUI for some period of time, then that means that those transactions can't get included, and users get upset and they think that their transactions aren't getting included. They think that Avalanche is slow, and in reality, Avalanche is just adjusting. If they increase their gas price, those transactions will still go through just as quickly as normal. And we actually just released a tutorial that Raj worked on your team. So a shout out to him for building out a great tutorial on how people can adjust their fees in MetaMask. And the really cool part about dynamic fee transactions is how this actually plays into what's like the best behavior to use if you're using MetaMask or just issuing a transaction in general. And so that gets into like the fundamentals of what is the dynamic fee transaction. So before we get into that, what is like the original style of a transaction? And originally a transaction just specified a gas price. And so if you submit a transaction, there's a set gas price. That is exactly the price that's going to pay for every unit of gas. And so it's much easier to calculate exactly how much it's going to be charged. But if you don't know what the base fee is going to be and you don't know how much it's going to cost to get included, then you might want to include more information. You might want to have some mechanism to include more information. So you can say, well, if the base fee is this, I'm not willing to pay it, versus if the base fee is this, I am still willing to pay it. And so that's where EIP 1559 dynamic fee style transactions get involved. And so those, instead of providing a static gas price for that transaction, what they do is they provide a maximum fee and a maximum priority fee. And so what that means is that instead of providing a gas price of 50 GUI, they provide a maximum fee of 100 and a maximum priority fee of, let's say, 10. And so what happens is if the base fee stays at 25, then they're not going to pay the full 100 that they said that they were willing to pay. Instead, it's essentially like a second price auction, where instead of paying the full 100, if the base fee is 25, they pay the 25 plus their tip on top of that. So if their tip was 10, then they would end up paying 35, or essentially a little bit above what the base fee is, as like an extra thing in order to incentivize people for it to be included. And so what you can do is you can actually put in your actual true price. How much are you willing to pay for your transaction to be included? And you're not actually going to pay a substantial amount more than it unless the base fee actually goes up that high. So that if you submit a transaction with a max fee cap of 100 and a priority cap of let's say 10, and suddenly the amount of network utilization goes up and the fees jump from being pegged at around 25 to 50, you're still not going to pay 100. You're going to pay 60 GUI for a transaction to be included in block at 50. That has a base fee of 50 GUI. And so that's a really cool thing, because now you no longer have to worry about, oh yeah, my transaction is stuck, I have to issue a new one. You can actually just submit one transaction where you submit your actual true maximum price that you're willing to pay and the actual price that you're willing to pay above the base fee in order to get included a little bit faster. And so if you just have that information, you can very easily decide it and include it in your transaction, and it'll be executed as quickly as possible. The thing that I've realized now, and is that no one actually knows what their actual true price is. Nobody submitting on MetaMask has any idea how much they're willing to pay if suddenly network utilization goes up. They're really just click a button, MetaMask recommended this gas price that costs, let's say, 5 cents. Yeah, I'm willing to pay 5 cents, and they go. They don't really think about, well, if the network utilization goes up and let's say I'm like doing some swap on Pangolin, well, it kind of depends how much you're willing to pay. Maybe the trade isn't as good at that point, or something like that. So they don't necessarily think about that. So what we did in the tutorial is we wanted to just recommend reasonable values for those. And then the assumption was kind of people will just use these reasonable values, and then things will just work better. And if people want to take the time to actually evaluate and decide what their actual maximum they're willing to pay is, then they can do that and they get an even better user experience out of it. Unfortunately, with MetaMask right now, the way that their suggested gas prices work is that if you put in a maximum fee and maximum tip that are substantially higher than what their recommendation algorithm finds, it provides a warning. And we didn't want to scare users, so we decided, and they're also, in addition to not wanting to scare users, they've also made some huge improvements to their gas price estimation. So it is actually a very, very, very good, user experience to just use that as well. So we decided not to say this whole spiel about how great dynamic fee transactions are and how people can use them to just submit their true price and get a very seamless user experience. But we're also working on a tutorial of how to do this in JavaScript as well. And so that is going to be a little bit more detailed about this, about how this works, and provide exchanges as well as other integrators with the opportunity to use this type of transaction and get an even better user experience.
Yeah, I was just reviewing the PR for that today. And so there are a couple C-Chain APIs. There is C-Chain.get base fee, and there's also C-Chain.get max priority fee per gas. So these are RPC calls that you can call to get those two values from which you can calculate the max priority fee per gas and the max fee per gas. And then you create a transaction of type 2, which is the IP 1559 with, I'm guessing, Web3 or Ethers, and then you send that to the full node. The tutorials should be merged in the next couple of days, as he mentioned. Something that came to mind as I was thinking about that, and if you don't know the answers, it's totally fine. Presumably subnet EVMs also have the IP 1559 style dynamic fees. And so I'm wondering, what are the implications if somebody launches a subnet and launches a Gabriel token and uses it instead of AVAX to pay fees, and then they're giving fees to the validators? Does that throw off everything you just said, or does the same kind of paradigm work in that world?
Yeah, the same paradigm works. They can still pay the fees in the native token of that subnet. And so yeah, they can still pay the fees with that. So it'll still work exactly the same way.
So they could do like ETH, they could give the tip to the miners or the validators, and they could burn the other one, or I suppose they could give it all to the validators or whatever.
That would be a modification. We did actually provide that modification. So that's another optional config that people can use to say what should be done with the fees. And I'm actually not entirely sure how that modification works, if that's sending the entire fees to the validators that are proposing it, or if it's just the tips. But either way, anybody that wants to can very easily modify that. That's probably a 10-line change in order to change where those fees actually go. Right now on the C-Chain, those fees are just sent to what we have taken to calling the black hole address, which is just 0x01 and then a bunch of zeros. So it's just a hex address that does not correspond to any private key that we have. If anybody discovers it, we've also added in protection. But they would think that they were very rich, and Zenotrace would show that they're very rich, but we've actually added in protections to make sure that if somebody does discover that collision, they do not get access to the funds.
Oh, really? So my quantum computer in my closet, I can't use it to get that money then? Dang.
There's a lot of money in crypto that your quantum computer can get. So I wouldn't worry about it too much. But
I'm going for them Satoshi coins, baby.
Yeah. The interesting thing, so this is actually one of the changes that additionally we migrated in from Go Ethereum. And it was really interesting to see why this PR existed, because I kind of saw this PR and I thought, they're really protecting against the hash collision. That's, I mean, a lot of things would be broken if somebody was able to find this. So, or if somebody found a reliable way to find, if a quantum computer was able to do this, things are going to start breaking crypto all over the place, not to mention the actual financial system and the entire internet. I mean, things are very broken if crypto
nuclear
breaks.
launch codes, HTTPS.
Yeah, exactly.
I mean, everything is pretty screwed at that point. Yeah,
exactly. So there's a lot to worry about there, but people can do a brute force search. And so the really interesting thing was on this original PR, they found that there was some estimate. I didn't look into their exact math, but it was, I don't know how back of the envelope it was, but there was some estimate that in order to find one of these, to find a collision with an address, with a specific address, actually, it would cost about $10 billion. And at that time, I think Uniswap, or it might have been another exchange, a decentralized exchange, had more than $10 billion on it. So if you think about it, like if you can actually find one, it actually becomes not such a bad idea to spin the hash power to do that. So it was pretty interesting to see that cryptocurrency has gotten to a point where, the assumption that cryptocurrency is built on is that, hash collisions, they're not going to happen. And it was really interesting to see that in at least one context that's starting to be a little bit less secure. Not that I'm particularly worried about this. I don't think anyone is going to be investing $10 billion on the off chance, because there is variability to this too. I think that was an expected value calculation. But I'm not that worried about it, but it was just really interesting to see that even by back of the envelope calculations, we're getting to that point.
So I want to go back to one thing that you said a few minutes ago about people not knowing what fee they should pay. And now I'm just kind of putting my thinking cap on, and I'm wondering, I think maybe we're just going about the fee paradigm all wrong. Because I guess what people really care about is like, how much am I going to pay for this transaction? Like total, not like how much am I going to pay? Like what is the gas rate? It's just like, it's almost like we need to recalculate. Like I'm willing to pay $200 of gas, but I don't know, like based on the price of ETH, like how much gas is this actually going to take? Like what's the price going to be like when it executes? And I wonder if we need like a paradigm shift there of like thinking about it differently, trying to price it in like total value. Cause like, it's hard to set something that would be like static for like all transactions, because not all transactions are priced equally. They cost different amounts of gas. Like doing a simple, like if I was sending AVAX from person A to person B is very cheap, but calling a function that mints 20 NFTs is going to be quite expensive. So I almost want a gas independent way to just price my transactions. Just say like, I'll pay like whatever the actual gas fee is, as long as the total cost is like under this amount.
Yeah, I mean, that's a great point, because most people, if you're just looking at in MetaMask or just in general, this parameters you have to set are the max priority fee and the max fee cap, but that's not really, you're completely right. That's not really what people care about. One thing that MetaMask does, however, provide, like, I think it's in actually the next screen over, it does provide, here's the total cost of this transaction. And that's even easier to do so when it's in just like a simple transaction that doesn't have these dynamic fee parameters. It's just a simple gas price, because then there's an estimate of how much gas it's going to take to execute that transaction, as well as a hard cap on the gas limit of that transaction. And you can see a little bit more clearly exactly how much it's going to cost. But you're definitely right. We could definitely provide a better user experience there if we just made sure that people were seeing the numbers. Here's what I expect to pay based off of the current base fee, current network conditions. Here's what I'm willing to pay up to in order to get my transaction executed quickly. And the other variable here too is, this is just to be eligible for inclusion. If is really a huge amount of contention, then just because their transaction is staying above the base fee doesn't necessarily mean it's going to be included within 2 seconds or 3 seconds. There's not like a exact amount of time that it's going to take. And so, like, if the question is how much are you willing to get your transaction included in the next block, your transaction still might not get included in the next block, so it's not a perfect answer. I'm paying to be included in the next 3 seconds, because that's not exactly a deterministic question where there's not a set price that if you pay, you will be included in the next 3 seconds.
I am wearing my MetaMask shirt.
What's that?
I am repping MetaMask today. I do have one of my.
Oh, is that a MetaMask shirt?
Yeah.
Nice. I don't think I've ever seen MetaMask gear ever.
Oh, they actually, I have to say, they have the best shirt designs in crypto. Like,
I definitely don't see the little fox on there though. Is there anything that looks?
It's a kaiju fox.
Oh, that's actually really cool.
It is a kaiju MetaMask shirt. Yeah, it's like Godzilla monsters. Like it's
Godzilla
cool.
versus MetaMask.
Yeah, basically, it's one of them. Actually, they have some multi-armed. I don't know all my kaiju, but
where'd you get that one? I know you've been going
just the MetaMask merch store online.
Oh, really?
I just saw there. Yeah,
nice.
they actually have a really strong brand and like designs for their merch. So yeah. I looked, they had a lot of cool shirts that I liked, so I just bought a couple because like I use MetaMask every day. I can support the brand.
One question for you guys then, maybe you guys have a little more info on this than I do. Any chance of an Ava Labs merchandise store? I get questions all the time from friends when I'm repping my Avalanche things. I've got my Avalanche notebook right here, and I got Avalanche socks for my birthday from the company, which was a very nice present. And yeah, I don't know when the store is coming. I know there are a bunch of knockoff stores. I know Joe has a Avalanche themed Supreme sweatshirt, which was really cool. Really love that. But I think it's mostly done, at least for publicly, like not, I know we got some degree of Avalanche swag, but I don't think we have a public store yet. Do you guys know if that's coming soon or anything cool coming out?
So yeah, I also have a lot of bootleg merch, which is fun. Don't worry, like we're not going to sue you if you buy it. I don't know if I'm allowed to leak alpha, but I would say if you're interested in Avalanche merch, come to Barcelona.
Yeah, that's a good hint. That's a safe hint. So I think it's been an hour somehow, and I always like to be super respectful of people's time. Also, I know Aaron's on the East Coast. There were 2 more topics, but I think we might have to kick them to another day. We were going to talk about native assets versus ERC20s, and then I wanted to dig on ARC20s because I know a lot of people ask me about them all the time, but I think both of those are probably a rabbit hole, and I want to be respectful of your all's time. So
I think if people want to see, if people want to hear what Aaron has to say, they might want to follow him on Twitter.
Yeah, I don't say all that much on Twitter. I've been trying. I think I've talked to both of you guys in the past about advice about getting more involved on Twitter because I do want to tweet more, but I never actually take the time. But if I get a huge surge of followers after this, maybe I'll have to start streaming my thoughts to that platform.
What's your username?
And then also we'll leak another little bit of alpha. All 3 of us will be attending Avalanche Summit in Barcelona, and all 3 of us will be giving at least one workshop or panel. And so I know Aaron will be speaking. And so if you want to hear all about all the topics we talked about, definitely you're going to want to check out his panel, which is we're not announcing the topics just yet, but I think Jay is going to be putting out the event schedule very soon.
Yeah, so here, I think you guys can see my screen. Here is Aaron's Twitter account. It's his name, spelled Aaron Buchwald. And then, of course, here's Connor, Das Connor, DAS_CONNR. And then, of course, you can follow myself at CG Cardona, which is my initials. Hello. So yeah, we're all 3 going to be in Barcelona. We're going to be giving presentations. I saw, I won't share too much, but I saw the layout of the event. It is absolutely amazing. Like, again, if you saw what we did in Lisbon was just a seed. It was just a prototype. And the same crew that did that amazing work there is doing much, much more amazing work in Barcelona. I am so very excited, which is coming up very soon, of course. So we'll be flying out in just a couple of weeks. So I'm looking forward to hanging out with you gentlemen. Myself and Connor will be doing a Subnet show there as well. Everybody's going to be in town, so my intention is to get a handful of people and have them join us. So it should be a pretty fun event. So yeah, let's toss the mic around real quick. Aaron, any last minute thoughts? Thanks for joining us, man. We're going to have you back again, so prepare for it.
Yeah, thank you guys again so much for having me on. I love being here chatting with you guys. I know me and Connor were actually supposed to have we do this thing at Ava Labs where we have a coffee chat, since everyone's online and working remotely. And me and Connor are both busy people, and we've been rescheduling. Yeah, here's the coffee. We've been rescheduling our coffee chat for I think about a week now, and I think I messaged him yesterday. Well, let's catch up on the Subnet show. So
now you don't need to. You're good.
Yeah. Yeah. Thank you guys for having me on. It was great to be here. I love to talk about all this stuff, and I'm excited to see you guys in Barcelona.
Awesome. Yeah, Connor, any thoughts?
I would say I really wanted to just catch up, know what's going on in your life, but all of our lives start, so
yeah, well,
I know. So now I know I'm caught up. All right. Yeah, I'm good.
Okay.
Sounds good.
Great. Well, thanks everybody. If you made it this far, you are an absolute champion as always. We have some great guests lined up. So of course, tune back every week. If you're not yet following us on Twitter, please do. If you're not yet subscribed to the YouTube channel, please do. And please share it. We're trying to grow the reach of the channel, and we're also improving the quality and the quantity. So as always, just thank you so much. And we'll be back next week. Same bat channel, same bat time. So as always, from Snowflake to Avalanche and through consensus to the stars. Thank you so much, everybody. We'll see you next week. Cheers.